Hello, and welcome to today's session on how grid operators and technology innovators are powering a reliable, flexible, and sustainable future. I am Jarrett Campbell. I lead the marketing organization at Aviva, and some of the presentations you'll hear today will talk about some of the products. So we're really happy to have one of our customers in California ISO here today, as well as one of our brethren companies in ETAP in the Schneider family, talk to you about some of the things that are going on in the grid space. So I'd like to welcome them to the stage to join me. So first, I'd like to introduce Pani Kim Brevard. Pani is the Chief Strategy Officer, had to make sure I got that right, and the CEO of ETAP, where she leads business strategy, transformation, and global operations. She's been in the family with me and the Schneider family for a while, but maybe started at Gartner and then also in Vinsys and Aviva, and now Secure Power for Schneider and ETAP as well. So pleasure to have her. She will be our second speaker today. And our first speaker will be Henny Allerin. Henny has been working in the power industry for a long, long time, Henny. Maybe 18 years at Illinois Power, I believe. Another 20 years at California ISO.
Yes.
And he's currently let me get your title right, Henny, is
Executive
Director of Power System Technology, and is also part of the team that introduced the Nodal LMP market project at California ISO. So he's going to tell you a lot more about that. Well, maybe not that specific project, but some of the things that are going on at California ISO, and then we'll hear from Pane around how digital solutions are being used in this space. So with that, I'm going to give you
the clicker.
And I'll allow you to
allow.
And you're welcome to sit or stand, whichever you prefer.
I might stand. So, good afternoon, everybody. It is afternoon, right? I'm Henny Allerin. I've been with Cal ISO 22 years, so it's been 40 years in this industry. California ISO really started with only balancing authority market in California, which is 80%. But since then, 2014, we went to the energy imbalance market, Western energy imbalance market, which is really took us to the whole West. We have 22 entities now. And in that was 2014. 2019, we expanded, we became the reliability coordinator of the West. So we really have three different pieces we're trying to do. That gives you an idea, at least, where we are. The Western energy imbalance market is the orange one. All of these joined us, one or two every year. Or in 1 year, there was 3 of them joined, so we have 22 now. There is 2 more coming in 26. You can see the benefit of the Western energy imbalance market have to do with greenhouse gas, $7 billion saved since. And we actually now took that Western energy imbalance market, which is really only real time. You have to come in balance for the hour, and then we balance it in between. We are actually now going into EDAM, which is taking that model and going to day ahead, which 2 entities are joining us in 26. And that it's going to be interesting. It'll be the first in the country doing that. Resource capacity, that gives you a little bit of mixture of what we have. It's interesting, southern companies were talking about, I think 11,000 solar. We have a lot more than that. And really storage, we have a lot more than that. And I have a slide that kind of gives you at least the idea. And this is true peak and this is capacity. So this is the number that you want to look at. We're trying to hit 2045 to be zero, carbon free. That's a very lofty goal. We are supposed to be 60% by 2030. We already crossed that one. So we got that goal in the bank. Renewable. It's interesting when you start seeing things, because 10 years ago, we didn't have more than a few hundred solar megawatt. And now we're sitting at 21,774. I update that one every time I present because it changes. That's wholesale solar that's in addition to the rooftops, which is somewhere around 12,000 megawatt rooftops, and it's been going on for a while. And our peak on wind really stabilized. We're somewhere around 6,500. it haven't moved. So the wind is dying in growth, but solar is still going. The installed battery capacity has been rocketing. 6 years ago, we only have 10 megawatt. And we went from 10, and it's been exponentially sitting at 14,000. And we think we're going to actually go up to 50,000. And this is how you can accomplish that piece. So that addressed some, if you remember, Paul talk about what are we going to do. Some of that solution is materializing with storage. There's a lot of electric vehicle. California have 1.5 million. It's about a third of all electric cars in California. So that gives you an idea. The grid have to be ready for it. We track the steepest ramp. And if you notice that duck curve that I'm talking about, that's the term we came out with 10 years ago. We quit calling it anymore because it's actually not looking like a duck anymore. It's changing because of the battery. But we track the worst 3 hours that you have to ramp so much. And just to put things in perspective, we hit peak in 50,000 megawatt in 2006. And we didn't hit that peak for 16 years. And then in 2022, we went to 52,000. It's not that our load didn't go up. It's that efficiency was happening all these years. And if you have efficient in light, LED, and so on, then you don't hit that peak because you're getting efficiency out of it. But 52,000 in 2022 tells you that I think we got all the efficiency out of the way. So anytime you get a heat wave, it's going to hit a new peak. So transformation for the electric grid, it's going to be tough. People think electric cars, hey, you know, we have 30%, 40% sales. Well, 40% sales does not materialize into 100% electric vehicle because whoever buy electric one have to sell the old one, give it to somebody else to use it. So it takes 20, 30 years to replace that concept completely. But it's moving. But that means if it's completely moved 100% electric, we're going to have a little bit more demand on the grid. You heard about data centers is booming. AI is picking up a lot of electric need. And we're seeing those things happening. School bus, they don't replace their buses except so many years because once they buy it, until it goes old, 30, 40 years later. But when this happens, it's probably going to be electric. The important part, we've been talking about distributed energy resource or demand response for a long time, but we didn't do anything with it for 30, 40, 50 years. It's going to happen. So, and I'm just introducing concept here. We really need to do a lot of demand. If you noticed demand response, which is DER now is we call distributed energy resource, which could be solar, electric vehicles, battery, anything. And if you notice, the grid was one way, right? We have a generation, transmission, you get to distribution, and you ship it down. It's changing. In the last 10, 15 years, that's completely different. We got rooftops everywhere, so now the generation could be anywhere. It's interesting, the last 3, 4 years, we start having distribution nodes that we always thought distribution node are load. Not anymore. We have distribution load in our system that are actually generators. It creates problem in the concept because we take the load and distribute it to all the load, but you have about 100 different nodes that are not really consuming, they're producing. So we have to change a lot of our concept of how we're going to handle these things, and it's not as easy. Storage device is going to boom, double, maybe triple, and it's still coming. The last thing I'm going to introduce, it's a one slide, but I'm not really talking about a lot of it, is distribution system operator. We have California ISO is in the transmission only. We're not in the distribution. We don't have jurisdiction, but we know to do all these things that we keep talking about and we hear about, it needs a distribution system operator. It won't be us. It would be a third party. It could be the utility, it could be the distribution company, or a third party. And just to give an idea, I'm giving you a list. I usually have a slide on each one of those. So I'm overloading. I won't give you all the stuff. But to do a DSO, you need to actually have a distributed distributed energy resource registration. You got to go register all the resources, where it belongs and what node it's in, what's the address, who's going to pay for it, who's going to get paid. And you go down the list, their capability, how often can they be just, charged and discharged and so on. And the concept is you want all this stuff to be aggregated. You've heard, Nest and thermostat that you can control, but for a transmission and for CAISO, I need megawatts. It's kind of hard to move a kilowatt. That doesn't do anything. So we need that aggregation, otherwise it won't be feasible. But this is the system that we've been advocating. We're creating a framework and working with the different utilities, trying to figure out what's the best way to create that structure so we can actually have a truly distributed energy resource that you can control and deal with. DER types, you heard that term DER, distributed energy resource, and people say, well, what's a DER? So I'm giving you a list. It could be any of those. Notice hospital have generation, they only use it as a backup. There's fuel cells, demand response, vehicle to grid coming up. So there's a lot of things that you can actually, if you aggregate it, then it becomes very powerful to control the grid. This is our energy storage progress. You can see 2019, 770 megawatt we had. So you can see it's moving up capacity-wise, and it keeps going. That's 24. I think we're sitting at 14,000. Really, it's interesting. No matter how much we thought about storage device, until you have them and start using them, you realize, wow, they're really very beneficial. I didn't realize it's a great idea. I think we have more storage than anybody else. And that really helped in the solar, because we have a lot of solar and renewable. I guess so this is a solar production, and that changes from one day to the other, as you can tell, right? Different days, you're going to get a different one. Sometimes you get 5,000 megawatts, sometimes you get 14,000 megawatts. And because of that, you have to improve your forecast, and you also have to have something when the solar doesn't show up, when it rains, when you have a scattered, you need something else. So you have to have this, and this is where the storage comes in very handy. So that gives you an idea of 7 days in a row. Wind is even more finicky. This is what you got for wind on 7 days. There's no prediction from one day to the other. One day you can say, wow, I got like 4,000 megawatt. Another day, I'm not even getting 1,000 megawatt, not even 500 megawatt. So, but the geographical dispersion is really helping a lot, because it's not sunny everywhere, and it's not overcast everywhere. It's not windy everywhere, and it's not dead everywhere. So it kind of helps in our footprint. Just to give you an idea, back in 2023, we have a solar eclipse. That was a partial solar eclipse. And you can see we dropped almost 10,000 megawatt. Now, when we can predict it, we know solar eclipse is coming. We know how to fill that gap. Now, because that gap have to be filled by other resources. We didn't have as much storage at that time. We have a lot more. And there is no solar eclipse for the next, I think, 15, 20 years. I'll be retired by then, so I'm not worried about it. Yes. So what levers must be pulled to create more favorable load shape? Because the concept is no longer the peak. The old days, you have generation, you have load, you focus on the peak, and it says, how am I going to serve the peak? And we used to build generation to meet that one peak. That concept is completely gone. Now we say geographical location and dispersity is actually helping a lot. We want to create solar. If we have extra, we want to ship it to other area. So we got the whole West, and this is why we have Western Energy Imbalance Market making $7 billion, and this is why the one is moving to day ahead. You can track condition at our site. It's always current. It's always wonderful to look at different things at any moment in time. You can have it on your phone also, and it's really been very challenging. And I remember when we had less than 1,000 solar everybody's like, I don't know how we're going to go. Another 1,000 or two, we won't be able to run the grid. We actually also have inertia issue a few years ago. And what we done, we went and bought inertia. I don't know if you know what inertia is the ability to recover the system fast when something happened. So we had to go buy it because we didn't have it. With 14,000 megawatt storage, that concept is gone. Now we can sell inertia if you want, if anybody wants it. And what that happened is we used to lose like 1,000 to 2,000 megawatt. You are required to recover that in 10 minutes. And maximum from the time it happened till you recover, you have to be 15 minutes. The last one we had lost 1,000 megawatt. It was recovered in about less than a minute because the storage, they just move. The storage device, it's not like a RAM. There is no inertia. They can just jump up and give you 1,000 megawatt. When you have 14,000 megawatt, it works much better. And we're still going to go with more solar and more battery, and hopefully we can accomplish what we're trying to accomplish. That's all.
Thank you, Henny. I promise next time we'll give you like a whole session on DSO and you can go into all the details because I'm sure they would love to hear your thoughts on that. So, what we'd like to do now is move to, I guess, keep the story in California, right? And we're going to talk a little bit about Moreno Valley and how ETAP has been working with them on some of their challenges in the digital space.
Thank you. Thank you. Are we on? Awesome. So just a quick show of hands. Who here has actually been a part of any type of digital transformation? ERP, CRM, engineering software. Keep it up. Actually, keep it up if you were able to complete it in time, under budget, and it was 100% effective the moment you went live. Because I'd like to envy you, that's all. Oh, okay. So a lot of what I'm going to talk about really is a case study of, the work that we did with Moreno Valley. So Moreno Valley is a relatively small, young public utility in California, but they're rapidly growing. Now, the population there you see is 208, but I think we looked yesterday and it was more like 220?
Yeah, it's like 215. Next census is coming.
Yeah, right. Just a few people over 5 years. But with that being said, so Hanny, thank you for that presentation because all you did was just validate a lot of the pain points that this utility had. A variety of disparate systems, a lot of different data structures across those systems. I think at one point a customer called it disco era hardware, right, and equipment within their utility. So how do you go ahead and manage all of your new distributed energy resources, including solar, battery, all of that into the grid? How do you modernize while also keeping it running? So that's the toughest thing about digital transformation. I've overseen a number of large programs, including CRM, ERP, and the toughest part is trying to modernize and getting your people and your organization ready for these newer capabilities while also keeping things up and running, right? So it's almost like this dual architecture that you have to run. And that's not always simple, but it's needed because this is not so much a technology shift. It's more, I would say, an evolution and complexity that the utilities have to deal with today. That being said, they knew that with the population and a lot of the energy resources out there were going to increase over the next 5 to 10 years, they knew that it was time to start integrating, unifying, or at least getting much more centralization in their data and that visibility and access to data. And more importantly, how do you do that while maintaining the reliability and efficiency of your grid? So, as you look to modernize, they partnered with ETAP, in which we created a digital twin, right? A virtual replica of their entire power system and grid. What that enables them to do as they go ahead and operate their grid is have better confidence in a lot of the decisions that they're making without actually applying it to the grid. So it's simulate before you operate, right? But before you even do that, like in any digital transformation, a lot of those disparate systems that they had, one, they knew they needed at least some data commonality, right? So redefine your data structures. 2, start integrating them so that you can, again, you have access to all of this data. We all do, whether it's financial, whether it's operational, engineering data, but none of it actually matters if you can't contextualize it. So having that situational intelligence by integrating a lot of these systems together is really what empowered the operators within the utility to make better decisions without impacting the grid. Because that's the last thing you want to do, right? Is be able to modernize, but then interrupt the efficiency or resiliency of your grid as you're doing so. The other thing that Moreno Valley did was actually leverage our real-time capabilities. That being said, it's similar to what I referenced earlier, where you really can simulate before operate. So as you look at additional energy resources coming onto the grid or applying to connect to your grid, how do you ensure that that load, that request, isn't going to cause some significant voltage variations in your grid, change the performance of your grid? So with this real-time capability, you can actually go ahead and take a look before you decide anything, apply some of those parameters to your grid, depending on whatever the situation may be, whether it's weather-related or it's, a significant load coming online. And with that, from a real-time perspective, you're able to dispatch a lot of these decision-making capabilities out into the field in a safe and resilient manner. So some of the benefits, as you see here, a lot of the feedback that we got from Moreno Valley was really at the people level. Because when you have access to all of this data and you have the capability to look at what everybody's looking at, right? Because you want a single version of the truth, and having that digital twin, having that very centralized capability and that virtual replica, which becomes the backbone of your operation, when everybody's able to leverage that same insight and same information, you're operating your grid much more safely. So again, a lot of the value that ETAP provided, and it was also because of the willingness and readiness of the utility itself. So we know software, there's plenty out there, and really software is there to help with decision support. But the most important thing is being able to make those decisions confidently and safely. So when you're able to integrate a variety of different applications, right, onto a unified platform and ensure that everybody's operating off of the same data and information, it really does help not only, I would say, operate your grid more efficiently, but also you're enabling your grid to be future ready for more resources, because now you have common data structures across a variety of different sources. You're now able to integrate it, understand what the weather patterns may be and how it may impact your operation, right? Or if there's, again, another large load coming on, how does that really help you manage your load fluctuations? And then ultimately, I would say that it really came down to Moreno Valley's willingness to accept the change. So to the point I made earlier about digital transformation, there's a lot of capabilities out there, but you need to make sure your organization is ready to accept those changes and evolve with those changes, because power is no longer this one-way flow, right? It's this chaotic two-way ecosystem that's forever evolving. So with that said, it's going to be really important that not only are you equipping your organization, but the people behind it are also equipped, and that you also enable them to be a part of that journey, to accept the new technologies, but also be able to leverage it and really gain the value of the optimization that the technology provides. Okay? So, I guess that's it. So anyway, so again, a majority of my presentation is not so much about the features and the benefits of all of these individual software capabilities, which we already know ETAP is great. But the most important thing is, having run so many digital transformation programs for Schneider, for Secure Power, and now even here at ETAP, I cannot stress the importance of making sure that not only is your organization ready, but also your people. So having advisory services or professional services to complement what you're trying to do from a digital capability is crucial, because none of this will matter if your operators, if your people are not behind that change, right? And so it's important to go ahead and start with those small wins, start integrating the data, start looking for those data sources or areas within your operation that you can normalize, and then try to create or pull more value from that data by contextualizing it and providing your people with much more situational intelligence to make decisions. Okay? So I know that was super invigorating. I'm eating into your lunch, but I hope you enjoyed it and that it was informative. Again, my CEO is somewhere here for the more technical questions, But again, more importantly, if you have any questions related to digital transformations or how to even start this journey of applying a digital twin to your utility, I'm here. So thank you.
Thank you, Pane. Thank you, Pane. You said that was it, but it's not really it. That was the end of the intro. What we really wanted to have is a dialogue with you guys and give you a chance to ask some questions. We got some, a practitioner every day working in the field doing this stuff. We've got someone that's looking over from a digital perspective, a lot of projects in this space. So I definitely want to invite you to ask some questions. I'm going to kick it off to get us started while you think of your questions. But Lisa here is got a microphone. So if you do have a question, you can raise your hand. She'll bring you the microphone and we'll field those. But to start with, Hanny, I wanted to touch on something we saw in the keynote this morning. Fred Gautamel was talking about the change from linear energy flow to bidirectional energy flow, right? And I'm sure this is something you're dealing with every day with all the DERs and everything. Like, what are some of the challenges that you've seen, and where do you see that we need to innovate in order to address those challenges?
That's actually a good question. And some of our challenges we solved, some we're still trying to figure out. As I mentioned, you expect distribution to consume only. When they start producing, it creates a problem with the whole concept of I know how to take the demand and divide it into the different nodes to run a power flow to know where your flow is in the grid. But when they start actually producing, that concept doesn't work at all. So we're still trying to figure out, what do I do with these nodes? It doesn't like anything below zero on the flow going in the wrong direction. So that creates a problem. The other part is the amount of electricity we have to add on the grid. If it was just pure generation, it won't work. And I don't know if I'm going to extrapolate what you saw in the slides in the presentation. I think when he mentioned we built our building back in 2010, and Iraq only had 15 kilowatt of power. These days, it's 150 kilowatt of power, and it's moving to 1 meg of power. That is not linear at all. That also means when we build our building and brought power supply, we're thinking, 15, maybe go to 100. We have plenty of room. We don't. We no longer have. Because every time we take a server out, we put another server in, it actually needs 3 times the power. So now you got a challenge. Do I have to bring more electricity into that building? And that's a major expense. But we're not the only one. Everybody's thinking AI, but really AI is creating that problem because it's creating GPUs that are very power consumption. But then the servers that are coming with replacing the old server, whether it's an operating system that grew or whatever, it's really taken, 10 an order of magnitude, right? It already moved an order of magnitude from 15 to 150, but now it's going to go another 6-7 times. And, we don't have enough room for the power supply. Neither do we have room for physical. And the other part is now that you generate so much heat, now you got the next problem. You need bigger air condition. We need more power. So it's really an exasperate the problem. So you really have to be thinking demand. And this is why we start talking, it's time to do demand. You cannot say, I'm going to grow the grid 3 times as much. I don't know if you know, but transmission line takes about 7 to 10 years to build. So it's not like you can just...
I heard they were relatively cheap to build too.
Yeah. It's just several $1 million per mile.
In 7 years. But you said you'd be retired in 7 years. Right?
Yes. 40 some years. That's good enough. So these are the challenges that I think the industry and everybody have to face. It's back into the whole system. You cannot just expect utility to fix it or CalISO to fix it. Everybody have to find a solution. Efficiency, demand response. You cannot just take the grid to be twice. It's not going to happen. We are doing a lot of planning and plan for transmission lines to grow and so on. But Some of our power plants, and this is all over the country, they're designed for 30 to 40 years. Some of them are running 40, 50, 60 years. So, that's not something you sustain, but you say, well, I don't want to shut it down because I need it. So there's a lot of things that when you have that increase, all of a sudden, you end up with that problem. Electric vehicles, everything is adding to it.
Yeah, great, thank you. Padme, for you, you've been doing the software thing for a while, right? And you've been through several transitions and hot topics and things like that during your time. How is digital twin, AI, advanced analytics really changing the way utilities are engaging with us as suppliers? And, maybe what are some of the things that they need to be thinking about as they get into these projects? Because they do want them to finish on time and under budget and with 100% effect.
Don't we all? Don't we all? And that's a great question, right? So when it comes back to software, like I said earlier, it's always about decision support and enabling decision support in a way that you as the operator can be more confident. So when I think of the digital twin being that live virtual or virtualized replica of your power system, the fact of the matter is that you can apply or simulate certain changes and troubleshoot things more effectively and more quickly, right, without actually impacting the performance of the grid. I think that's a huge benefit, especially for operators when you're trying to ensure that whatever decision you make is not going to impact the resiliency as well as the safety of your grid operation. And then also just having that real-time capability, especially when you start integrating it with your GIS or other applications, being able to effectively determine if a weather pattern or if a certain weather condition is really going to negatively impact your system, you could troubleshoot much more, I would say, confidently, right, and proactively, as opposed to wait and see because you had legacy systems or disparate data sources in which you yourself are trying to manually interpret and then draw analysis and insights from, to only then manually push out to the field. So being able to have all of that within fingertips reach, and then also having that data normalization across those disparate system really does help from, I would say, an efficiency standpoint, just from an operational efficiency standpoint.
Great. So does anyone in the audience have a question for our experts? Lisa's ready to run with the mic.
I'm dreading my boss asking me a question on stage. I
noticed he's doing it.
Oh, Tanesh,
I'm ready.
You're up.
No, I ask her questions every day, so I'm gonna ask Hani.
I don't have anybody to ask her question, but go ahead.
So when you talked about buying inertia, so my ears perked up. So I would love to hear a little bit more of how you're doing it, because all the other ISOs and grids are facing similar challenges. So that would be insightful. The other question I have is with IBRs and now with data centers, there's going to be a lot of power quality strain on the grid. Now, I understand CalISO is not responsible for power quality. You have standards, but how are you going to ensure that people are following those standards as a grid operator? So those are the two questions.
Oh, tough. So I'll answer the first one on IBR. So we actually evolved over time. When solar came in, there was no inverter based. It didn't have a inertia. Pretty much everybody just put solar, push it to the max, and that's the plan. But I think 6-7 years ago, I thought, okay, this is not going to work because we have so many, thermal generation is going away. So the governor response that's supposed to pick up the frequency is not there. So we actually put rules about inverter-based resource that have to have some amount of inertia or governor response simulation. That's why it's called IBR. And so that actually worked because when the frequency dipped, they all pick up as if they have inertia, even though there is nothing spinning, right? Storage came in, and storage really changed the dynamic because a generator usually pick up, 5 megawatt a minute, 10 megawatt a minute. If they do 15, wow, that's a really good generator. And then battery came in, and a battery could be 100 megawatt, and you ask them to go up 100 megawatt, they shoot it in 1 second. So we have to work with the batteries. Is, oh, please, when I ask you to move, move slowly. Unless I really want you to move fast, but take your time, 5 minutes if I ask you for 100 megawatt. So over time, we really perfected our automatic generation control and frequency response. And so these are the kind of things that we actually improved upon to make sure we get there. 5-6 years ago, we didn't have the batteries and we didn't have the solar. Pretty much everybody just goes to the top. We also didn't have economic curtailment. We invented a term called economic curtailment because tagging people says that's an oxymoron. You either have curtailment or you have economic. What do you mean economic curtailment? But for solar, we actually said, I know you can produce that much and you stay producing your max, but if I have reliability issue, I can ask you to curtail. And technically, I do economic curtailment because I ask them to go down. They put their price. When I ask them to go down, I pay them for actually going down. So that addressed that issue. Now you're saying what happened to how do you handle inertia? Obviously, we're handling the West. I can't buy inertia from the East. That doesn't work. But we are intertwined company-wise. So when we looked at and calculated our own inertia, we felt like if we lost something, you have 15 seconds to recover, and that is just not happening. And you can calculate all the stuff we do all the time. All utilities do it, and we decided, okay, we want to buy it from somebody else, and we actually put a bid out, and some people bid on it, and we bought it, paid them money. And so when we have an inertia, they pick up that frequency response to recover. And I think we stopped doing it 3-4 years ago because we no longer need it. Does that answer both questions?
Lisa, there was one in the back. Thank you.
Thank you. I guess this is a question to both of you independently. When you think about really the North American market or really the sort of the global market, do you feel like there is let's say an ISO that's doing something that's creating envy from you around the way that they're working or the work style or their asset portfolio, sort of in terms of how it is against sort of the either the North American market or your own market? And I guess from a software perspective, what clients are doing things well from your experience in terms of implementations or how they're leveraging software or how they're being innovative?
Do it.
So no, I love that question. So let me first address the North American market and who's doing it well. So what I can say from my experience, well,
I knew he was going to.
Danny is obviously the epitome of it all. But I would say on a more serious note, what my experience has shown me over the past 2 years is that actually a lot of the utilities are learning as they go. So what I'm seeing, even with like interconnection requests with the utilities, and not everybody has digitally modernized their capabilities, right? What I'm seeing is that they're asking questions when they're not even sure what to ask yet. And I think on both sides, on the demand side and on the supply side, it's being a little bit more patient with one another, right? As far as understanding that, yes, I have a large load. I would like to connect to your grid. I need 800 megawatts, but you have 2, right? When you're making that submission, and then I would say within that submission itself, some of the data that's being provided, the utilities are asking questions, but they're not quite sure how to actually model it back into their system because it's all different data, right? It's all different data models, different data sources. So what I would say is there's no one utility who's doing it great. I would say all utilities are actually trying as best as they can to understand the implications of all of these various energy resource types, especially with solar, wind, even diesel farms, right? The fact of the matter is utilities are at least asking questions. And I would say for the demand side, it's also being patient and understanding that these questions or this connection to with large loads is also new and it's all happening so quickly that patience really is a virtue on both sides. And as far as some of the best practices, it actually goes back to the organizational readiness, right? So like I said, there's a lot of great software out there. And obviously within ETAP, having your electrical digital twin and having that virtual replica truly is valuable. But it also always goes back to the utility or the organization's readiness to accept that change. Because you're talking about disparate systems that have been built, not in parallel, right? It's some systems come online and then it has its own data model. And then you have another group, and then the utility who's only handling interconnection requests that has a different set of data. How do you integrate all of that into a platform? So making sure that your people are ready for that type of modernization is also quite critical.
Excellent point. I'll just add that our industry in 95 were very helpful to each other, cooperation and collaboration everywhere. And then market comes in and the industry thought, I'm going to not show you what I have. And it went from 95 for 10, 15 years. There's no collaboration, as if we're competing against each other. And sadly, there was some of that, because especially in the East, where you can join one ISO versus the other, they were stealing each other and so on. I think we stabilized that piece. And I see that the last 3, 4, 5 years is a lot more collaboration. Europe was ahead of us in solar and wind, so we actually start visiting them and learning from them. ERCOT is ahead of us in wind, so we said, okay, let me see your challenges there. We are now ahead of solar on solar and storage. We get about 50 to 100, 50 countries that come and visit us. And we spend a day or two. I've done like 10, 15 of them this year. And they come and ask, how are you dealing with this? What are you doing with that? So we all compare notes. When it comes to software, it gets a little more complicated, because if I have a Siemens system, somebody else have GE Harris, somebody have ABB, it's like, oh, you can do this. Oh, my vendor doesn't do that. So that's a little bit harder to implement your things. And sometimes it takes years to replace. So this is as bad as transmission. It takes 7 years. Anytime you have software, you're pretty much married to that software for 5 to 10 years. And you invested so much in it, it's hard to switch. But we keep comparing notes. I know all the ISO meets once a year, and they compare notes on everything. Vendors, software, security, what works and what doesn't. And we all work now together very well. And also, I think the utilities also, they've been working better in that regard. So I think everybody realizes, like, we all have problems to solve, and let me see how you solved one problem. I'll show you what I solved in the other problem. And that's working much better. I didn't like that 10 years in the middle where everybody is thinking you're competing. It's like, I'm not competing with you.
And that goes to the point I was making, like, everybody's learning as they go. And for the utilities, I would say the past 2 years, again, just seeing this insane surge of demand, right? But capacity is so limited. So for one utility who may have expertise in wind, what you're seeing more and more of is this consortium effect, where you are trying to learn off of one another. And to the point, Hani, that you made about, the difference or the different systems that a utility or an ISO may have, this is where, like, the value of agnostic software comes into play, right? Being able to work with a myriad of asset types. So definitely look for software that gives you that flexibility and the agility to not only move within your different software systems, but can also manage and connect to the variety of assets that you have. Because we all know, even in our cars, it's not just one supplier. It's a variety of, low voltage, medium voltage. It's just, and your cooling, everything in your data centers, they're all different. So again, focus on making sure you have a software that's agnostic, that's flexible, and allows you the agility to move, forward, even backwards if necessary.
And we in CalISO made specific decisions, like we have the message bus, service-oriented architecture. That way every application is isolated from all application. I don't have to do point-to-point interface. That was critical 20 years ago, and we went that way. Common information model. Yes. There's a lot of people that, I don't want your model. I say, it's not my model. It's the standard that we're all going to use, not my standard. And so we kind of start convincing everybody to use the same standard. So some of that stuff you really have to put your foot down and say, hey, We all have to be consistent and use software. The last thing we've done, and in the last maybe 5 to 10 years, is do component. Before you buy an EMS, and the EMS have AGC, SCADA, state estimator, RTCA, VSA, DSA, all in one. And if you don't like the answer the vendor is giving you, you don't have a choice. You got to replace the whole thing. We broke all of this up into pieces.
A very modular approach.
Very modular approach. So if I want state estimators from a vendor, we actually have VSA from one vendor, DSA another vendor, state estimator a third vendor, and the EMS happen to be the same vendor, but it's component. So I can replace the EMS or I can replace state estimator. And that's how you have to think. It's back into how do I make it open system? How do I make it, it's not 100% proprietary that I cannot move and integrate.
Okay. Well, thank you very much. If this were like the Academy Awards, they'd be playing me off the stage at this point. So I just want to thank our experts for their insights. And I know that both of them will be around and would love to talk to you more during the event. Invite you to come to the Innovation Park and learn more about some of the software solutions that are in use in this space. And thank you for your time and attention today.
Thank you.
It is.